All right, so at the end of this video, you should have a strategy for determining the direction of DNA synthesis, given a template and a primer. You should be able to think about the difference between copying DNA and amplifying DNA, which is what happens during PCR. And also you should be able to think through multiple cycles of PCR and make predictions about it. Now, remember on PolyLearn, there's also some readings and some objectives that follow up with this. And with those, you should be able to distinguish between processivity and fidelity. You should understand where 3' overhangs come from. And also you should see that there's different choices when you're using DNA polymerase, and molecular biologists use their properties to make informed decisions. But first, some review. All right, so imagine you have a partially double-stranded DNA molecule, shown below here. Now the two strands are different lengths, but they're still complementary base pairs and anti-parallel strands. All right, now you're going to take that molecule and add DNA polymerase and also nucleotides, A, G, C, and T to that. And the question is, what are you going to get? So you have 4 choices down below here. So I'm going to ask you to pause the video and choose which one you think is the correct product. Okay, you've unpaused the video, so you're ready to see the answer. It's actually D here. So we can add onto that shorter piece of DNA, but only in one direction. So we're going to review now, in case you aren't sure why, the different properties that all DNA polymerases have. And the first one is that they can only add nucleotides to an existing strand. So they can't start from nothing. They have to add on to a piece of DNA that's already there. All right, so let's draw a single strand of DNA. Let's label the 3' end with the hydroxyl group over here, and this is the 5' end. Now, this has all the information for making the other strand in it, but DNA polymerase can't use it this way. It needs a double-stranded region. So let's draw in a little double-stranded part here and make this anti-parallel to the main strand. This will be the 3' end down here. But now we're all ready to go. This little piece here is called a primer, and what it is it provides that existing strand for DNA polymerase to work off of. All right, the other important property that all DNA polymerases have is that they add nucleotides to the 3' end of that existing strand. So they can only add nucleotides to the 3' end. So in our drawing, DNA polymerase would be able to start here at the 3' end of the primer and add on nucleotides in that direction. So let's draw it out a little bit. Here's our DNA polymerase. It's moving in this direction relative to the template, and it's going to keep adding those nucleotides on at the 3' end. Now in textbooks, this is often referred to as 5' to 3' synthesis. 5' to 3' synthesis. And that just refers to the fact that we're adding on new nucleotides at the 3' end.